Welcome to the Explainer. If you're here, you're the kind of learner who really wants to know what's going on under the hood of our digital world. Today, our main goal is to completely dismantle a huge myth. You know the one, when most people think about software development, they instantly picture some lone genius in a dark room. They're wearing a hoodie, fueled by way too many energy drinks, just frantically typing into a terminal until, boom, a multi-million-dollar app magically appears out of nowhere. But as we're going to see from our sources today, writing the actual code, that's really just a tiny, tiny fraction of the whole shebang. So think about the apps you literally use every single day. Maybe you're scrolling TikTok or Facebook, maybe you're booking a ride on Grab, sending some cash through Gcash, or just trying not to get lost using Google Maps. You might even be thinking of the learning management system you use for school. Now, I want to challenge you a bit. What actually goes into building those seamless, perfectly smooth digital experiences? Because unlike a physical machine, software is totally intangible, right? It's this incredibly complex web of programs, data, documentation, and configuration files that all work together to tell a computer what to do. And getting all those invisible puzzle pieces to fit perfectly together, well, it takes a whole lot more than just knowing a programming language. Okay, let's dive into our roadmap for today. First, we're covering the reality of software. Second, programming versus engineering. Third, the software crisis. Fourth, the engineering team. And finally, ethics and trends. Section 1, the reality of software. To really wrap our heads around how professional software is actually built, let's look at a physical analogy. Imagine for a second that you're in charge of building a brand new hospital. You wouldn't just hand a crew some cement and be like, all right, start laying bricks, right? No way. That is a guaranteed recipe for a collapsing roof. Before a single brick is even touched, professionals have to meet with the client, draw up meticulous architectural plans, figure out the budget, create a rock-solid schedule, and ensure everything meets strict safety codes. Well, building software requires those exact same rigorous steps before a single line of code is written. Instead of pouring concrete, software engineers are constructing massive, highly intricate digital structures. Which brings us to this pretty weighty definition from the IEEE. They're basically one of the top authorities in the field. Now, what's really interesting here are those two words, systematic and disciplined. Software engineering isn't just hacking together some quick fix on a Friday night. It's a highly structured, strictly quantifiable approach. And it doesn't just cover the initial build, it covers the operation and the maintenance of that software over years, or honestly, even decades. So if we take that heavy IEEE definition and boil it down, it really just means this. Software engineering is the entire process of planning, designing, building, testing, deploying, and maintaining software, all in a super organized way. By sticking to these proven, structured methods, teams can guarantee their final product is reliable, secure, scalable, and easy to fix later. It's all about looking at the entire life cycle of the product to make absolutely sure it actually solves the user's problem. Section 2, programming versus engineering. So this highlights a stark contrast between what folks think software development is and what comprehensive engineering actually looks like in the real world. Let's break this down. Programming is mostly just about writing code to solve one specific task. It's usually done by one person with pretty minimal planning. Think of a computer science student sitting down and whipping up a simple calculator app in an afternoon. That's programming. Software engineering, on the other hand, that encompasses the entire software lifecycle. It relies on huge, collaborative teams working to solve massive, broad business problems. It demands extensive documentation and serious, comprehensive management. It's the difference between building a quick calculator and developing a massive system like the Gcash mobile banking app over several years. One is just a task. The other is a full-blown professional discipline. Now, to really get why we need all this discipline, we have to look at what makes software so unique. The crucial point here is that software behaves completely differently from physical machines. For starters, it's developed, not manufactured. Once you create it, you can distribute millions of digital copies for basically zero cost. But here's the wildest part. Software doesn't physically wear out. Like a car engine wears down from friction, right? Software doesn't do that. Instead, it ages. It ages because user needs change, the underlying operating systems get updated, and brand new, highly aggressive security threats are constantly popping up. So to survive that aging process, the software needs continuous, complex updates just to stay functional and secure. Section 3, the software crisis. Those strict, disciplined rules of software engineering we just talked about, yeah, they weren't just invented for fun. They were actually born out of sheer necessity after some massive, catastrophic failures. If we look back at the 1960s and 70s, computing power was exploding, and software projects were getting incredibly huge and complex. But developers were still essentially just programming. They didn't really have these structured processes in place yet. Because of that, the industry slammed into a dramatic turning point that we now call the software crisis. We're talking projects routinely blowing past their deadlines, burning through budgets, and churning out completely unreliable systems that would just fail the minute they were deployed. It was this widespread chaos that forced the industry to create the rigorous engineering rules we rely on today. Let's look a little closer at exactly why those early projects went down in flames. The main culprits were basically a total lack of standardized processes, incomplete documentation, terrible team communication, and severely inadequate testing. Plus, requirements were constantly changing. Imagine a university hires a team to build an enrolling system. The team just starts coding right out of the gate. No roles, no design plan. Halfway through, the university is like, oh hey, actually, we need online payments and mobile access too. Because the team just hacked it together without a flexible engineered plan, the entire system totally collapses under the weight of those new requests. That was the software crisis in a nutshell. Section 4, the engineering team. To make sure those historical disasters stay in the past, today we rely on heavily structured teams. Modern software is almost never built by one lone wolf. It requires a totally multidisciplinary squad. You've got the systems analyst who translates business needs into technical requirements, the UI/UX designer making sure it looks great and is easy to use, front-end and back-end developers actually building the interfaces and the server logic. Then you have database administrators keeping the data secure, QA testers relentlessly hunting for bugs, DevOps engineers automating the deployments, and project managers desperately trying to keep the whole thing on budget. And this brilliantly illustrates the sprawling, interconnected ecosystem required to build modern software. Literally, everyone relies on everyone else. Section 5, Ethics and Trends. Now, as we look to the future, we absolutely cannot talk about engineering without talking about ethics. Software engineers make incredibly weighty decisions every single day, decisions that impact user privacy, financial security, and honestly, even physical safety. I mean, it doesn't matter how beautiful or fast an app if it completely compromises your private data, right? If an engineer spots a security flaw that leaves personal info exposed, it is their strict professional duty to report it and fix it, not just sweep it under the rug. They literally hold the keys to our digital lives, so managing that responsibility is just as crucial as writing clean code. Let's move to our final point and see how all this builds into where the industry's heading. Because tech evolves at lightning speed, engineers have to constantly adapt to cutting-edge trends. Right now, a massive trend is AI-assisted coding, which is completely supercharging productivity. Teams are also heavily leveraging cloud computing so they can scale infinitely. And they're using microservices architectures, which basically means building an app out of small, independent pieces, so it's way easier to update. And maybe most importantly, there's a huge shift towards cybersecurity by design. This means security isn't just an afterthought bolted on at the end. It is baked right into the blueprint from day one. So, we've walked through the reality of the software lifecycle, the vital difference between just coding and true engineering, the crisis that shaped the modern industry, the brilliant teams doing the work, and the trends pushing it all forward. But as we wrap up this explainer, I want to leave you with one provocative question to chew on today. What happens when the software you rely on most simply fails? The next time you open up an app and it just works perfectly, take a quick second to respect the invisible architecture, the rigorous discipline, and the massive teams working tirelessly behind the screen to ensure our digital world keeps spinning. Thanks so much for joining me today. Keep learning and keep questioning how the world around you is actually built.